And then next device is diode AC switch. So it is maybe you can relate triode and diode AC switch. What is the difference between triode, triac, and diac? You have a gate terminal here, right? So that gate terminal is not there. If I remove the gate terminal, it will be a diac. See here, equivalent circuit also. I have the current flow happening in both ways, but I don't have the gate terminal. இங்க வந்து ஒரு gate terminal இருக்கும். If you see the diagram for triac, you see you have a gate terminal near MT2, but that one is missing here. So you don't have a gate terminal here. That is going to be diac. Diac is a diode AC switch. So it is a 3-layer, 2-junction, 2-terminal device. MT1 is main terminal 1, MT2 is main terminal 2. Okay, so I don't want to say cathode and anode because you'll get confused. So that's why they use the terminals MT1 and MT2. MT1 is main terminal 1, MT2 is main terminal 2. So it is a bidirectional avalanche diode. So it does not have any control current, right? So it has two junctions, J1 and J2. See, if you have a controlling terminal called gate, so everything will depend on what you give to your gate. But since you don't have any control element gate here, it is just a bidirectional avalanche diode. So diac represents BJ bipolar transistor. The central layer is free from any connection within the terminals. So it is very simple. The characteristics is simple. As the doping level, everything is going to be same. It is going to have an identical characteristic for positive and negative half cycles. So as you increase the voltage, the current will increase till it attains breakover. So once the breakover happens, then the voltage will remain constant, current will increase abruptly. Same way here also, when you increase the current, when you increase the voltage in negative way, the current will increase. It will reach breakover. It will reach breakover. So once you reach breakover, then voltage remains constant and current will be same. It will going to be constant. So in the positive half cycle, MT1 is positive with respect to MT2, whereas in negative half cycle, MT2 is positive with respect to MT1. So the characteristics are going to be exactly identical. So you can see how the devices, the graphs are going to be exactly identical. Okay. So at voltage less than the breakover voltage, very small amount of current is going to flow through the device. So device is said to be in off state. So this what we have seen is applicable for all the devices. So when the voltage reaches breakover, the device starts conducting. It exhibits a very small negative resistance, and then the current will be starting to increase. So compared to SCR, where you have a very large negative resistance region, but here I don't have that. So it once breakover happens, you have a very small negative resistance region, and then the current is going to increase abruptly. So negative resistance phenomenon is very weak here because I don't have the terminal called gate. Whereas in other devices like SCR, Triac, where you have a controlling terminal called gate, the negative resistance graph is very prominent. So it will reduce and then it will increase enormously. But here you see the negative resistance is very weak. So it is slightly having negative resistance and then it is increasing abruptly. The same thing is happening for negative the reverse bias characteristics also. See, in these devices, since they have identical characteristics in both forward bias and reverse bias, the magnitude of current flowing in forward bias will be same as the magnitude of current flowing in reverse bias. Usually in PN junction diodes, the forward bias current will be in milliamperes and the reverse bias current will be in microamperes. This is what we have studied. But since this device is exhibiting the same characteristics in forward and reverse bias, both the currents will be in the order of milliamperes only. Whatever is the magnitude in forward bias, the same thing will be in reverse bias. If you have microamps in forward bias, you will have microamps in reverse bias. So if you have milliamps in forward bias, you will have milliamps in reverse bias. Okay. See, conventional PN junction diode will not have identical forward bias and reverse bias characteristics. It's completely different. But see, all these devices, Triac, Diac, all these devices, since they are identical, they have the same forward bias and same reverse bias characteristics. See, in this device, even if you interchange MT1 and MT2, and if you use, it is not going to have any effect on the device behavior. So even if you interchange your terminals, it is not going to affect the behavior of the circuit. Okay, so that is going to be a diode AC switch. So diac is not a control device because you don't have a gate terminal, right? So it is just a triggering device used in triac phase control circuits used for light dimming, motor speed control, and heater control. So diac is not going to have any gate terminal, right? So those devices having gate terminal can be used for triggering, but this device does not have gate terminal. So this device can be used to trigger other devices having gate terminal. So for example, triac, SCR, they all have gate terminals, right? So this device can use to trigger triac, so that the triac will be controlling the application in real time. That is what the application is given. See here, diac is not a control device, but it is used as a triggering device in triac phase control circuits used for light dimming, motor speed control, and heater control. Okay, this is the application for diac.